to explain how it would work to a small business. I mean, these types of devices and some of the stuff that Microsoft is doing now with the lower tier SKUs of Windows Server are really targeted at small companies that really don't have a lot of IT expertise. And so you get situations where somebody buys one of these and they plug it in, but it never really runs at full speed. They never really get the full benefit out of it because they don't understand SMB multi-channel, or their workstations don't properly support it, or something else like that. Now these out of the box, you just plug it in, it works. You don't have to do any configuration. You don't have to do anything. It will work on these devices. But the clients on the network may need a little setup. You may have to pick up some hardware, something like that. So in order to troubleshoot it, you have to understand what's happening. And so I'm going to start at a very basic level. When you have a computer, like say a desktop computer, and it's got multiple Ethernet cards, it's not plugged into the network at all right now, we're going to plug in the first network card. What happens? Your computer sends a broadcast to the network. It's a special type of broadcast. It's called a DHCP request. If you've got DHCP configured. If you don't have DHCP configured, in this case with SMB multi-channel, you're asking for trouble. There's probably, you could probably ask about that on the forums. It's not really relevant for this video, but you know, if you're not using a DHCP server, the time has come. Use a DHCP server. It makes your life easier. If you're worried about configurations or security or something, you should look into a decent switch like this 24-port MikroTik cloud switch, which I'm going to hopefully review at some point in the future. It's got two 10 gig SFP plus ports and 24 1 gig ports. Going to talk about that more in a minute. You can use something like that for better security and better control. Just set up a DHCP server, honestly. The time has come to set up a DHCP server, and I guarantee that you already have a piece of hardware on your network that will totally be a DHCP server without any headache. When you plug your computer in, it sends a special type of broadcast called a DHCP request. And that DHCP request is answered by your DHCP server. Now your DHCP server responds with a usable IP address to the computer that you've plugged in. And there's other information in there, like a gateway and a DNS server. A DNS server is what converts names, like google.com, into an IP address that your computer can then access. Well, in the DHCP request that your computer sends, in the case of Windows, it sends the name of the computer. And so a typical home network or a typical small business network might be 192.168.0. something. All of your devices are 192.168.0. something. And so what happens when you plug in the desktop computer with that first network, so let's say that the computer's named like desktop-B85 something or other. You plug it in and it sends a DHCP broadcast, it sends a DHCP request, and it says, you know, my name is this, and you know what, you know, where's the DHCP server? The DHCP server makes a note of the computer's name and responds by assigning it an IP address. Now, if you're running a Linux router, certain Cisco routers, certain other things, nothing else happens. It ignores the name of the computer, doesn't do anything with it, and assigns it. If you're on Active Directory, which is an enterprise technology, the computer's name will be added to DNS. And so DNS is also serviced by your Active Directory controllers typically, or at least the DNS is said to be Active Directory linked, meaning that records can be looked up in DNS that have to do with Active Directory because Microsoft. And so you end up in a situation where that desktop B85, if you do a DNS lookup through your DNS servers that are typically an Active Directory server, it'll return the IP address of that computer. That's normal enterprise setup. Well, with these, on a home network and a small business network, you don't necessarily have an Active Directory controller. You don't necessarily have the situation where your DHCP server can communicate DNS records to your DNS server. They may be the same machine, they may be different machines. A typical home router or a typical small business router is handling DHCP and DNS. We like pfSense. We did a video on setting up your own home router with an operating system called pfSense, which is based on FreeBSD. And out of the box, the DHCP server on pfSense will just give you an IP address. It can be configured to take the name of the computer and add that to DNS, and it can also be configured to serve as a DNS forwarder or a DNS server. And so I would recommend, if you're using pfSense or using another router, that you configure it so that when your DHCP server hands out a lease, that it also configures a DNS entry. You can run ipconfig/all and look at your DNS servers in the list. If it looks like a public IP address, like 4.2.2.2 or 8.8.8.8 or 8.8.4.4 or like 205. something, if it's not 192.168. something, then your DNS servers are out with your ISP, and your ISP's DNS server is not going to be able to tell you what the LAN IP address is of your, of your Thecus server or of your Windows server or of your other Windows 10 system on the network. In that case, Windows falls back to a broadcast. It'll send a broadcast that says, hey, who has this name? Windows is actually very chatty on the network. Like if you set up a packet monitor and you're doing capture on the network and you're looking at all the stuff that Windows is doing, it's very, very chatty. So the machines are always talking to each other. They're always sending broadcasts and just all kinds of crazy stuff happening because Windows. But the deal with the broadcast is that it can't handle multiple IP addresses. Wait a minute, multiple IP addresses, what are you talking about? We got the computer, we plugged it in, DHCP server gave it an IP address. We get that second network adapter, or second, third, and fourth in the case of a 4-network port adapter like the one on the desk here. You plug in the other network adapter, and then that also sends a DHCP request. They're not sharing the same IP address. That's not how this works. It'll send a DHCP request, it'll get another IP address, and so all of a sudden your computer has 2 IP addresses, or 3 or 4 IP addresses on your same local subnet, on your same local network. And then all of a sudden you're in an interesting situation when it comes to broadcasts and DNS. So if you're running a Windows server, a Windows DNS server, and it does the IP address lookup, then it will return all 4 IP addresses of your system. If you've configured the DHCP server to propagate the DNS entries to your DNS server from your DHCP requests, the DHCP responses, the DNS server should return all of the IP addresses associated with that particular computer for those active DHCP leases. Windows does that, but other stuff is not guaranteed to do that because again, SMB multi-channel comes from the enterprise. Microsoft would never, like, somebody's using something else for DNS or DHCP, what sort of blasphemy is this? If you're running a mixed network where you've got a lot of Linux machines and a lot of Windows machines, you can set up a separate segment of your network. You could set up a VLAN, you could set up a different physical interface and run Windows DNS and DHCP, at least a Windows DNS forwarder, and sort of overcome those problems. The Windows 10 threshold update, the August 2016 Windows 10 update, added a lot more stuff and a lot more robust sort of features to the algorithm for SMB multi-channel, so that is less necessary than it used to be. The very first version of SMB multi-channel, this is just kind of a tangent, I'll probably skip over this part, but the very first version of SMB multi-channel actually worked best when you had different physical networks for each interface. So if you were going to run a computer with 2 Ethernet interfaces, you would get 2 switches and run 2 cables, and one would be 192.168.0 something, and the other one would be 192.168.1 something, and 2 and 3 and 4 and so on and so forth. And that worked really well with broadcasts too, because when Windows sent a broadcast on the first network, it would return 1 IP address, but it could send a broadcast on the second network, and when it sent a broadcast on the second network, because those broadcasts were isolated from the first network, it could actually get a second IP address from that broadcast. So that would actually work. That would actually work really well. But Microsoft sort of recognizing, it's like, well, wait a minute, these technologies are being used sort of outside the enterprise. They're being used in small and medium-sized businesses, sophisticated home setups. We should make the protocol a little bit more robust. And so they did, and it works better, but you should understand that originally it was architected to have totally separate networks, and that's important if you're running Linux too, because Linux has got a little bit of a lag time in terms of their implementation, and a lot of the documentation and examples that are out there for Linux actually still have it set up with multiple different subnets. So it's sort of a fun, interesting note. So if I could summarize all of that, it is, does it matter if you're not using Windows for your DHCP server or your DNS server? Both of these devices, because they come with Windows storage servers, totally do both of those things even without Active Directory. You don't have to have Active Directory. You can just roll with it. And the answer is a resounding maybe. But now you know. Now you know some steps that you can do for troubleshooting. Now you know that you can do an NS lookup from the command prompt and see what you get in terms of returning an IP address. If you get 1 or 2 IP addresses for a particular workstation, now you know what to look for. The second thing that can interfere with SMB multi-channel, a lot of motherboards have a built-in NIC. And there's a particular type of technology called receive side scaling. Receive side scaling means some different things in terms of implementation and the book definition and what you actually run into in the real world and what you run into in the enterprise. What receive side scaling is supposed to be, this is a generic definition that has some very subtle nuances and some very, sort of loopholes and some gotchas, is that when you have a high performance network adapter, it is supposed to be able to route the incoming packets or outgoing packets from the network to a specific CPU core or a specific interrupt handler to make it more efficient. Okay, what does that actually mean? Got a gigabit network adapter, and if the CPU is too slow to keep up with that gigabit network stream, and you get a 4-core CPU, normally the interrupt would only be serviced by a single core. Well, with receive side scaling, the network hardware can split up that queue into multiple queues and have each queue serviced by a different CPU core in parallel. Normally, I mean, think about it. Normally, networks, especially when we're talking about these older network adapters like these Intel 1000 GTs, the network stream is just one thing. You've got a single network stream. This card's got 2 networks on it. You got 2 network streams. There's 2, interrupt queues, and the interrupts happen, and they're serviced by a single CPU core. Great. Well, on modern multi-core systems, there's a technology that sort of underpins that called MSI-X. MSI-X takes sort of a global mode interrupt and sort of shunts it to a specific CPU core. And the specific CPU core can be picked by software, can be picked by the operating system if you've got true and proper MSI support. And so there's a PowerShell command in Windows called get netadapter RSS. And in get netadapter RSS, there's an indirection table entry. And the indirection table, if it's empty, then your CPU doesn't properly support RSS, although technically it does, and we'll talk about that in a minute. But the network adapter that's in your computer doesn't properly support RSS. And so you will not be able to use the whole multi-core parallel processing multi-queue thing to handle multiple network streams efficiently. It'll still work, but it's just not going to handle the multiple network streams efficiently. And how that will manifest if you're using SMB multi-channel is that you've got 2 network cards and you're running it, and it looks like SMB multi-channel is working, but the performance is actually awful. But there's some workarounds, and there's some things you can try to improve performance. And you typically would see that with a low performance, older Core i3, crap like that. Some hardware is advertised as being receive side scale capable. Like for example, Intel i217, 218, 219V, those NICs are part of the chipset. They're not really part of the PCH, but there are dedicated resources provided by Intel as part of the Intel processor for the i217, 218, 219V network adapters for motherboards that choose to incorporate them. And if you look at the Intel documentation, it's like receive side scaling, totally supported, totally there. Not really, sort of. It supports receive side scaling, but only receive side scaling when it's shunted directly to, I think, Core 0. It's either Core 0 or Core 4, depending on which way you're going to count on the CPU. But you don't get a pick. Like the software, the operating system can't use MSI-X to route those interrupts to a specific core. So if you're running like holding at home and Core 0 is really busy and the operating system for Core 3 is idle, the operating system is not going to be able to shunt the interrupts that occur as a result of traffic coming in on the network adapter to that other CPU core to only be serviced by that specific CPU core. And so to say that receive side scaling is supported is a little misleading. And so that's sort of frustrating. So you can run into some really oddball situations. Like for example, there's an Intel workstation board that doesn't implement the i217, 218, 219V. It implements a Realtek and an i210. The i210 is external. It's a PCI Express interface on the motherboard. It's not provided as part of the CPU chipset interface. So that's kind of unusual. But then you look at it and it's like, wait, the Realtek supports receive side scaling and the 210 supports receive side scaling, but the i217, 218, 219V would not have supported receive side scaling properly. And so it doesn't work in a mixed configuration. However, if you disable receive side scaling in the drivers on motherboards that do have a mixed configuration, it will totally work. Sometimes it works anyway, depending on a whole bunch of factors. Like if you've got a mixed configuration where you've got receive side scaling on one adapter and you've got entries in the indirection table on one adapter and no entries on the other adapter, sometimes it will work. But like Z87 and Z97, if you're gonna run a card like this one, like this PT1000, this does not support receive side scaling with MSI-X. And so it's a little problematic in that regard. It'll work anyway. If you get a fast CPU using one of these i3, it's not going to work. This is an Intel 210. It's a single port card. If one of your network adapters has an indirection table and you use this card, this will work because it supports an indirection table, and this will work even with an i3. even with a relatively low performance i3, this will totally work fine. And you've also got other situations like this 4-port card. It's like, should I get a 4-port card and just run everything off the 4-port card? Not necessarily. Mixing network brands and network adapters, you know, Realtek plus Intel, doesn't really always make a difference. You know, with the mix configuration, the Intel and the Realtek, we're still able to do 200 megabytes per second on a modern board. It's fine. But there are weird edge cases. So like if you put two Intel 210s in a Z87 or Z97 board, it's problematic, and the reason is because of the DMI. The DMI interface, DMI 2.0, is too slow to handle that many interrupts. But if you can mix it with one onboard NIC and one added NIC, that doesn't overrun the DMI 2.0 interface, and everything works fine. If you move one of your i210s to like the PCI Express by 8 slot directly to the CPU, you'll have much better performance than when you're going through the DMI. And that's especially true if you're using a multi-port card. So it's something to keep in mind. Now for the Skylake systems, DMI 3.0 is so fast that for, you know, gigabit and even, you know, 4 gigabit, it really honestly didn't matter. So there's a full textual write-up on all these weird edge cases and the situations that you might run into on the forums. But you should understand that it's dangerous territory mixing cards that support MSI-X as part of RSS and cards that don't. And you can run a PowerShell command to see that. You can also run a PowerShell command to see the status of the multi-channel connections, and the guide for that is on the forum. And so hopefully this overview, hopefully sort of me explaining it, will help you understand what's going on, that you can make sense of the written documentation. It's a lot to cover in a video format, and it's a lot to cover, is, you know, like, well, what if this happens and what if that happens? This video would probably be an hour long, but hopefully the written guide as a companion to this explanation will help you understand. And also give you a little preview of the MikroTik Cloud Series switch. Now this is something that I picked up, it was on sale. You should be able to pick these up for less than $300, maybe even around $200 on sale. This is so far proving to be a nice little switch for like a home setup or a small business setup. It's 24 gigabit ports, it has a serial console. It also has two 10 gigabit SFP Plus interfaces so that you could plug this into a server or something like that. Now in terms of Linux multi-channel, I mentioned Linux multi-channel and it's almost there, but it's just not quite there. The only situation that I was able to get Linux multi-channel working is when the client and server had a matched network config. So if I had 4 gigabit ports in the server and 4 gigabit ports in the client, SMB multi-channel on Linux worked fine. If one of those connections drops or a cable comes unplugged or something like that, it will lead to data corruption. So you have to be careful about that, at least with the current implementation of SMB multi-channel. It also, a lot of the documentation seems to want you to do separate subnets. So I did separate subnets. I did not test it with each interface being on its own subnet because the software is not ready yet. I spent a lot of time trying to get a 10 gig server to a multi-gigabit client to work. That works great with Windows, but on Linux with Samba, it's not there yet. It doesn't seem to be able to deal with that situation. At least I couldn't get it to work. So if you get it to work or you have fun or whatever, let me know what your steps were. You can include it in the documentation. There's a link to the forum. Hopefully, in the not too distant future, when the Samba software is a little bit farther along, we could do another video or demonstration or whatever. SMB multi-channel, about 75% of the time, is a plug-and-play technology. If you have a lot of Windows machines or you have to deal with a lot of, you know, Windows copy file back and forth, this is not terrible. I still like Linux better, and I think Linux just generally works better. It's generally much less of a black box, but I figured that there were a lot of you out there that are running home setups with Windows and troubleshooting SMB multi-channel. We had some comments on the last Sneakers video that were like, hey, I plugged it in, some weird stuff is happening, and I messaged some of those people, and it's like, okay, well, let's create a video for this. Let's create a video that demonstrates it, and if you have problems or get stuck or whatever, come to the forums, and we'll do our best to try to help you. And there's a good write-up in the forum as well. So give it a shot, plug and play, not plug and play, let me know. I'm Wendell, I'm signing out, and I'll see you in the Level 1 forums.
Today is Tuesday, January 17th.
Oh, you know, 2017 has barely begun and it's already shaping up to be a golden year for fake news.
Now we're literally being showered with it. But here is some probably not fake news.
Probably. We make no guarantees. first up, a little bit of meta. Not really very many corrections from last week, or not really any corrections from last week. There's some clarification around like the Ryzen chipset thing, but I'm just going to wait until Ryzen's actually out to see how motherboard manufacturers have configured the resources on the motherboard to do stuff. Our store is operational. If you missed our video on the RAID thing, you should totally check out the RAID. It's sort of the 0th video on our storage server, our storage solution. We had a lot of fun shooting that. That was actually, I get to ride the rack like a skateboard, so that was fun. You should never use a 2-post rack for what we did, but it's fine. It's probably fine.
OSHA is not cool with that.
Yeah. Don't even want to talk about the OSHA angles for any of that. They'll just beep, gone, nothing. I don't know. Follow up. Yeah. Consumer Reports retested the MacBook Pro, which is kind of unheard of. Consumer Reports never retests anything.
Yeah. Well, I mean, maybe they would, but I don't think they would do it this quickly, or it would be like a news story if they did. Now the problem was not the battery.